what exactly is AP Statistics and what are we going to do this year? Let's kind of look at that. In AP Statistics, we want to know things about a population of data, and that population could be people, it could be things, but often a population is too large to adequately analyze every individual in the population. For example, if I want to know the average household income for every house, for the United States, I would literally need to find out the household income for every single household in the United States and divide by the number of households. But that's usually not practical. Our government attempts to do that once every 10 years with the census, but even then we don't quite get everybody, but we usually get a pretty good representation. So generally what we have to do is rely on taking a sample from that population in the hopes that that sample will tell us good information about the population. After we've collected that sample and we have some data, we do what's called exploratory data analysis. And this is pretty basic stuff. We make tables and graphs, and yet it's vitally important to get a sense of what that data is telling us. We'll be looking at that in chapters 1 through 3. Then we're going to go back and examine a little more closely how to collect data properly using a survey, an observational study, an experiment, or a simulation. Now, what do we do with that data after we've collected it, after we've looked at it? How do we interpret that data and make sure that it tells us about the population? Because we have a problem here. And that is that samples vary. We don't know for sure if our sample accurately represents our population. And if it doesn't accurately represent, how far off is it? What can we accurately infer about the population from the sample? So we have to go back and look at the other major branch of statistics, which is probability. Probability is how we develop statistical theory. We say, how likely is something to happen? We create sampling distributions, which are distributions based on a random simulation from the data. So we take lots and lots and lots of samples from the same population. How do those samples vary from each other? How do they behave? We use that to, along with the central limit theorem, which we'll talk about more later, but that is the big theorem in statistics, pretty cool one. We create statistical models, and then we use those models to help us re-examine our population. And we'll be doing this in chapters 5 through 7. Chapters 1 through 7, hopefully we will get all the way through in the first semester. And then our second semester we'll spend talking about inference. Inference is how can we use our sample data to make reasonable conclusions about our population. There's two types of inference that we're going to look at, confidence intervals and tests of significance. They all have the same underlying structure, but they vary in their details depending on the types of data, and that's chapters 8 through 12. Now let's just look a little bit about some things we have to take into account when we study statistics. First of all, if I give you a number, 10.5, that number is basically meaningless. If I ask you to tell me something about that number, basically you can say it's a number, it's a decimal number, that's about all I know. The data needs to have some context. So if I tell you the baby weighed 10.5 pounds, if you know anything about babies and birth weights, you would say, wow, that's a pretty big baby, because that's much heavier than the average baby would weigh. So this is one big idea. Data has context. As you go through the course this year, your work will be more writing than computation. Now, I'm not talking about writing long papers or essays. I'm talking about writing a few clear sentences establishing context and reasoning with the data. Do cell phones cause brain cancer? Okay, there was a man who sued a cell phone company a number of years ago because he was on his cell phone all the time. This was in the early days of cell phone, and then he got brain cancer, and so he was convinced that his phone had caused his brain cancer, so he sued the cell phone company. Well, many studies have been done, scientific studies, that show no relationship between using a cell phone and brain cancer. But he never gave up on his idea that he was convinced about that. And so this is a real problem in our society today. We have a lot of fake news out there. We have people who tell a story, a personal experience, and then They want you to believe a whole lot of things based on their story. And so we have to think, do we look at one individual story, or do we look at the big picture of statistical evidence? And that's becoming statistically literate and understanding how to look at data correctly is a really big deal in our society today with all the fake news out there. The famous advice columnist Ann Landers once asked her readers, if you had to do it over again, would you have children? Her results? 70% said no. If we had to do it over again, we would not have children. And she publicized those results, and it shocked everybody. The thing is, she didn't collect the data correctly. The same question was asked in a statistically designed poll, and the results were 91% said yes, if we had to do it over again, we would have children. Very extremely different results. Why so different? Well, Ann Landers didn't ask a randomly selected cross-section of the population. She just asked people to write in. Well, who were the ones that wrote in? The ones that were upset with their children. The ones that were happy didn't bother to answer the poll. So this was not a good representation of the overall population. So how data is collected matters. And we're going to be studying what methods generate trustworthy data and which ones don't. Now this is a graph, a really interesting graph, and being able to read a graph is really important because a graph tells a story. So when you look at a graph, what story is this graph telling? Well, you might notice it has a title, the number of deaths at the VA hospital in Northampton, Massachusetts by year and by shift. And then we have over here deaths on this left-hand column, and then we have years, and then we have a legend that says night shift is purple, day shift is green, and evening shift is orange. And you may notice that there's a few bars that are really high compared to the other bars, where there were significantly more deaths for this period of time from about 1990 to 1995. And in 1990, it was hit mostly in the night shift and a little bit in the day, and then the other 5 years, it was primarily the evening shift where we saw this spike of deaths. So when you look at a graph, can you read the story? Can you see what it says? Now, do we know why that happened? It turns out there was a nurse who was a serial killer. And when the hospital looked at this data and compared the deaths when that nurse was on shift versus the other nurses, they noticed this spike of data. And so this graph was a really important piece of evidence in bringing this nurse to trial. So one big thing you really need to know is that data vary. Now, if you think data is a plural word, so that this is grammatically correct when I say data vary or data vary. So get used to uncertainty. Statistics gives us a language to deal with uncertainty. Once again, statistics is a singular word, statistics. It could be plural if we're talking about individual numbers, but when we talk about the study of statistics, it's a singular word, gives us a language to deal with uncertainty. So get used to, in this course, not having exact answers, making judgment calls, and using weasel words. Okay, so weasel words are like tends to, about, approximately, and so forth. Get used to using those words when you write about data.